Hello everybody, my name is Ivo Tchaikovsky and I am UNC Charlotte Electrical Engineering Technology student, and today I want to present to you the electrical part of Industrial Automation Project for Senior Design 2 for Dixon Quick Coupling Division from Dallas, North Carolina. This is the project itself. It will be mounted onto the machine to control all the machine's functions. My part was to design this part. We see here stock light, disconnect switch, touch screen, illuminated emergency button, as well as remote start and stop buttons, including the joystick. The whole cabinet is powered by 120 volts AC, and as we can see over here, the top cable is the inlet for the power, and the bottom cable is the cable that connects the buttons and the joystick. That's the outside part. From the top over here we see 40 amp disconnect switch. Then we see 100 watt power supply with corresponding switch breaker. Of course we have a DIN rails. We have an Allen Bradley controller with high-speed counter, as well as 2-axis stepper control AMCI 3602 stepper card to drive two stepper motors with encoders. I'll show you guys that in a minute. Down here we have a DC motor drive that drives 1/5 horsepower geared motor. Over here on the left side we have two more breakers. This power supply is only 50 watts and it gives the power to the screen that's mounted at the door. This is the back side of the screen. We have the Ethernet switch that connects panel view to the controller and allows me also to connect my laptop and write a code. This part over here has been left out for the purpose of accommodating the back of the screen when the doors are shut. Down here we see this mechanical relay. I went with mechanical because I really like how it works. No other reason for that. I could have gone with the solid state one, but I decided to go with mechanical one. You can hear it, you can see it move, and I just like it. And this power supply right here has another switch breaker on the sides. This one is 6 amp and this is a 480 watt power supply that gives the power to that big motor, DC motor. Right here we see power supply for the stepper motors that is connected to the regeneration clamp, and that connects to the stepper motor drivers, and these connect to two stepper motors. The way this cabinet is wired allows the technician to basically work on any part of this cabinet without having to power up all the components. So for example, right now we can see that the controller is on and the Ethernet switch is on, but the power to the bottom portion of the cabinet, which includes two power supplies and a bunch of drivers over here, does not have a power currently. So in order for me to, for example, present to you the test mode of those stepper motors, I can flip the switch right here and the drive will basically turn the motor on and off, and we can see the stepping of the motor right here, and I can basically turn it off and not affect the rest of the system. And this is how both of those steppers will work when turned on. They're in synchronized right now, and I don't have an encoder connected to them, but this is the next step. Next thing I would like to talk about is the safety, which includes the emergency button. And the way I decided to wire the emergency button was to put it on the loop with the power supplies that provide the power to the moving parts, which are 3 motors. So I decided to float the ground, basically, if I may say so, where this switch will basically disconnect the ground to the power supplies and not affect the rest of the components power. So when we hit the emergency button, we will only disconnect the power to the DC motor and stepper motors. The power to the controller, the power to the Ethernet switch, as well as the screen, the buttons, and everything else will still be powered on. And this will be visible in a little bit further. I'll show you guys how it actually works. The other part of the emergency button, as you can see, there's 5 cables coming out of it. There's 2 terminal blocks. One is normally open, the other one is normally closed. The red one, it's disconnecting the power. It's on the loop with the power supplies. But the green one, it provides the signal to the PLC, and it also receives the signal from the PLC to illuminate the button. So it actually has 2 functions. For the purpose of this presentation, I also wired the left sensor, the proximity sensor right on this side. It's a capacitive proximity sensor. And this one on the right side as well. They're just wired as the push buttons to turn the motor on with the left one and turn the motor off with the right one. And if I wave a little bit in front of it, it turns the motor on, turns the running light on the remote, as well as stack light on the top of the machine. And now if I wave my hand or screwdriver right in front of this one, it turns DC motor off, turns on the red running light that will be replaced to the orange light just to match the stack light over here. This red light is reserved for emergency button, and not to confuse anything, but I will replace the red light with the orange light. So once again, I can turn it on with the button. I can turn it off with the sensor. I can turn it on right here with this one, and I can turn it off with the red light. I can also turn the machine with the touch screen, and I wired the bit to the start button, so when I press it, obviously the stack light is on and we can see that the motor is moving over here. And if I turn it off, sorry for the camera movements, but I can also turn it off with the stop light over here, and we can see that the light is yellow. I also want to show you how the emergency push button works. So I'll go ahead and I'll turn the machine on with the touch screen, and we can hear that the motor is running, and we can see that the stack light is on. So now when I press the emergency button, obviously we don't hear the motor running anymore. We get the red light, and we also get the code on the top of the screen saying that basically I can type in anything over here, but I typed in e-stop reset. That means that operator has to first unlatch the emergency button and then acknowledge the code on the screen with one of those buttons over here on the touch screen. But I also want to show you that once this emergency button is latched, the machine won't turn on. So we can get the red light, but we won't get the green light going unless we go ahead and unlatch it and acknowledge the screen message we can clear the alarm, for example, and close it. And now we can turn it back on. We can stop it. We can start it from here. We can stop it over here, and vice versa. We also have this solenoid that's already wired to the PLC. The air is connected from the compressor from the outside to this 31 inches in length air cylinder that extends to some length. I have thought maybe 52 inches, I believe. I wrote a little program just to demonstrate how that works. We can see the machine is in ready position, but it's off. So I'm gonna go ahead and turn the machine on, and it'll turn the DC motor on, and it'll let the air in and out of the cylinder indefinitely until I stop it. So let's go. And now it extends and the air goes back out. We have ordered the silencer for it, so that's on the way. I can go ahead and stop it.